Hello guys, welcome back to my YouTube channel. So today's daily LeetCode question is smallest string starting from the leaf node. So we are given a binary tree. So we will be given a root node of that binary tree. So the node values are from 0 to 25, which means it can have exhaustively small a to capital A. So if we are given 0, it means 97 plus 0. It means it belongs to small a. So the node value is small a. So we have to return a smallest string in exographically smaller. Means it should be the smallest string by forming from the root node to the leaf node. So let's understand this question, let's look into an example. Okay guys, now let's look into example, and here you can see that. So the possible strings are B, D, B, A, and for this path you can see that it's E, B, A. For this path you can see that it is D, C, and A. For this path you can see that it is E, C, and A. So whereas if you compare the four strings, you will get the smallest string, right? You will get the smallest string which is exographically smaller. Which is lexicographically smaller means it should be smaller based on its ASCII values and characters. So all are smaller case characters, so we need to compare only ASCII values of those characters in the string. So you can see that here it is the first letter is D and none of its first letter is C, so it is greater than this string, so it can't be our answer. So here we have D, C, A. As D matches the string, C is greater than the second character of our string, so it is also can be an answer. And here you can see that clearly E is greater than D, so it is can be an answer. So our answer should be this path only. So let's look into a clear understanding of what really compares the characters of a string. Okay guys, now let us say suppose you are given strings like A, C, D and B, and you have to compare it with A, B, C and D. So it first compares A character with A character. Hence both are equal, so we can't decide which string is greatest or which string is smallest. Okay guys, now it will compare second characters. So it will compare second with C with B, which means C is greater than B. Okay guys, ASCII value, if we compare ASCII values of these both characters, 98 is greater than, sorry guys, 99 is greater than 98. Yes guys, so you can simply now decide that this string is the largest string, this is the smallest string. Okay guys, so we will be going to use the same logic in our traversal technique while using DFS. So we can solve this problem using BFS and DFS. Now we will look into the possible answers. Okay guys, yes. Okay guys, now let's look into the BFS technique. So it is a bit complicated traversal to solve this kind of problem, but for just a concept of understanding, I will be discussing BFS, using BFS. So what will BFS do? BFS is nothing but a level order traversal. So it will travel each level at a time. So if we will store these levels alphabets are A, this level alphabets are B and C, this level alphabets are D, E, D, E. So if you can you observe any pattern of this? So if we will sort this level answers, we can see that first level will be A, second level smallest will be B, third level smallest will be D. If you reverse this will be our answer. Yes, this is our answer. So it is the technique of BFS. Now what is the drawback in BFS for using this technique? The drawback of BFS using in this approach is, so we are given a constraints of 1 to 8500. So it will take space of big O of n. So what is n here? N is the number of nodes. So we have to store the each and every value of the node in a list, two-dimensional list. Then we have to sort each other and taking value. It is more complicated thing. So now we will discuss the DFS approach. What the advantages we will be getting by using the DFS approach. So let's look into it. Okay guys, now we will be using result and other will be our path. So what is path? Path is nothing but the value from leaf node to root node. Means the value from root node to leaf node is D, B and A. So we will be traversing up to down, but our value should be in the reverse. Means it should be in the leaf node to root node. Okay guys, now we will be just storing the each and every path's value in the path, and we will be comparing it with the result. If any point of time we will be getting that path is smaller than the result, we will update the result. Okay, now the advantages are, so we will be traversing to each node. The time complexity is same, but the space complexity will be big O of 1. So hence now just look into the approach. So here this level our path will be A and our result will be null, because it is not a leaf node. So we will not checking any things until we found the first leaf node. So here our path will be A and B and our result will be empty. Here our path will be A, B and D. So first we will reverse this. It will become D, B and A. Then we will compare it with our result. So it is greater than the result. So we will be just updating the result with B, D and A. Hence result is null. So we have to just update our first value to the result. Afterwards, after the upcoming values, we have to just consider the smallest value. We have to update it with the result. Okay guys, now let's look into it. So here we will get that our result will be B, D, A, and now our path is E, B and A. So far we discussed that how to compare two strings lexicographically. So here this is the smallest one, comparing the ASCII values of the first both characters. B is smaller than E, so we will be considering this only. So next our path will be D, C and A. So our result is B, D and A. So this is clear cut that B is always smaller than D. So our result will be B, D, A only. Then next our path will be E, C and A. So our result is B, D, A. So you can clearly see that E is greater than B. So we will not consider this and we will return this to our main function. So this is my approach and institution video. So let's look into the code explanation. Okay guys, now let's look into the code explanation. So here first we will initialize our class member result, and we will create a string builder path, because we have to update our path by removing characters, so we can't take it as a string. So the dynamic string is string builder, so we can update our values in the string. So our result will be empty, and our path will be, initially it will be empty because we haven't appended any value to the path. So first we will insert our root value, so our path will become z. So is this node is a root node? No, it is not a root node, so we can't compare it with our result. So we will just traversal to the left node, then right node, then we will remove the character root node. Okay guys, now we will traverse here, so our path becomes zb. Okay guys, now is this a leaf node? No, it is not a leaf node, so it will traverse here, so our path will become zbb. So now is this a leaf node? Yes, it's a leaf node, so we have to compare it with our result. Okay guys, now we have to compare it our result. So our result length is 0, so at the first string we have to push this into our result. So our result now becomes zbb. So let this initial be our result. So now we will remove this character and we will just add this character. So our next path will be z, b and d. So I think it is greater than this string, because d have greater ASCII value than b, so we can't update with it. Then next we will look into z, d and a. I think this is the b is greater than a, so our answer will be z, d, a. Okay guys, now next path will be z, d, c. So I think c is a greater ASCII value than a, so our result will be this only. So we have to return from leaf node to root node, so we have to return a, b, z. So if you append the values, you can simply reverse the string and return. If you are inserting the values at the starting position, so you can directly return the result. So I hope you understand the all institution and solution video. The code is in the GitHub. Please visit. Thank you.